welcome back, Build Stuff. How are you all doing out there? So, our next guest is joining us all the way from Lincoln, Nebraska. Is that right, Bill?
That is correct.
Streaming to us underneath the Atlantic on tens of thousands of miles of fiber optic cable, which of course isn't going to go wrong because, hey, technology never fails. We'll be good. We've been fine so far. So Bill he's been working in software for a couple of decades now. He's done everything from troubleshooting dial-up modems to systems architecture, hands-on development, technology consultancy. And you're talking to us today about continuous security and how you can integrate security into your DevOps pipelines. Please give a big, warm Build Stuff welcome to my dear friend, Bill Dinger. Take it away, Ding.
Thanks, Dylan. I'm just upset I can't be with you all in person. We were talking before this, hashtag 2020, but I'm happy I'm at least here able to talk to you this morning. It's 4 a.m. here in the States, or where I'm at in the States. But I'm stoked because I love talking with this topic. So like Dylan said, my name is Bill. I'm a computer guy. And I'm here to talk to you about continuous security and how to integrate security into your build pipelines. This entire conference is about building stuff, and I strongly believe in building secure stuff. So let's talk about that. Let's talk about why do we want to build secure stuff? Well, security lapses ruin your customers' trust in your code and your product and what you're doing. This statement here is what I got up here is called the Rugged Manifesto. It's about how when we build stuff, we shouldn't just build something. We need to build software that is rugged. We need to build software that we know can be used in situations, can have people's private data, personal data, and can be compromised. And we have an ethical and moral responsibility to build code that is rugged. Now, all this is great, and all this sounds great, and I personally believe in it, but it's not easy, right? We need to make it a little bit easier on ourselves. So one of the things we try to do here, one of the things I've long tried to do in my career, and the rest of the industry has also moved towards, is to shift left. Historically, when we've done security testing, what we've all done is we've deployed the software, some website, hired a high-priced or not high-priced security consultants, come in, scan the website, give us this huge stack of security vulnerabilities back, and they've been like, fix all these things. In the meantime, the site's been up, probably had 4 other releases since then, and probably been hacked. And now you have to go back through and do all these changes and retrofit and all the rest. So one of the things we're trying to focus on here is to shift left. By that I mean, let's move testing and security and QA and automation. Let's do this early in the development cycle, including with security. So there's some quotes on this from a book. It's on my bookshelves behind me here. I think right next to my Fallout Nuka-Cola bottle. That talk about it's the book Accelerate, which is an awesome book. I would highly recommend it for anybody in the DevOps world, or as a system or lead architect on your team. And one of the things they did is they did scientific studies to figure out what practices improved 4 key metrics. The metrics they measured were mean time to recovery, feature lead time to production. And I'm going to forget to, because that's just how it works when it's 4 a.m. here. My brain, feature lead time, mean time to recover, deployment frequency, and I'm going to think of the other one in a second. They measured all these and they found practices that encourage these 4 metrics to be improved. What they found that teams that build security into their work do better at continuous delivery in all phases. When the tools provided make people's lives easier, the stuff they build is more secure. Okay, and we found that the very high performers were spending 50% less of their time remediating security issues. I don't know about you, but I would love 50% of my time back from remediating security issues. So how do we do this, right? Where do we integrate this? This is a pretty standard pull from Forrester, your typical CI/CD pipeline, starting at the left and moving a nice circle around. And what we really want to do is we want to shove our security tests as close to the left as possible around this build or infrastructure as code part, or in the unit test data code analysis. That way we can fail it before it ever even gets merged to trunk and deployed out to our environments. So before I talk about how we're going to do that, a couple of assumptions. All this code and demo I'm going to show you, by the way, All this code and demo I'm trying to show you, it's all built on open source technologies or close to open source technologies. But I'm showing you a couple different things. A lot of the demos around Jenkins. We talk about .NET, we talk about Java, we talk about PHP, we talk about Docker, we talk about JavaScript, and we talk about GitHub. Those are kind of the tools and languages that most of these OWASP tools support, which hopefully covers something you're using. I mean, this slide encompasses about 80% of modern software development. Hopefully it encompasses you. And also there's some experimental support for stuff like Ruby and Rust and some of the other languages that's just not quite out there, and I'll call that in a second. All right. So let's talk about OWASP and sort of talk about what I'm doing this. OWASP is a nonprofit in the United States. It has one goal, and that is to develop and improve security of software. I'm not trying to sell you anything. OWASP is not trying to sell you anything. They have one goal, and that is to make the web a more secure place, and that is it. They formed a long time ago in 2001 when the state of web security was awful. Good news, everybody. It is 2020 and web security is amazing. We never have any breaches. Let me tell you, it's been great, right? I never had any problems. Anyway, they've done good work, but obviously threats and security evolves. Besides some of the stuff we talk about, they provide probably the most famous work is the OWASP Top 10, but they also include stuff like the Cheat Sheet series, the SAM project, Zap Attack Proxy project. They host meetups. They probably have one in your town if you're in a reasonably big town. I believe Vilnius, for instance, has a OWASP meetup group. Also, that was my cherry Coke. Sorry about that. I hadn't pre-opened it. All right. So here are the tools we're going to talk about. We're going to talk about a couple different code tools that you can hook into your build pipelines, as well as a couple documentation tools that are also very helpful when you're used to building your software and building your rugged software in particular. So, well, the first tool we're going to talk about is OWASP Dependency Check. So OWASP Dependency Check is designed to protect you against the OWASP number 9. That is the number 9 on our top 10. So number 9 most common exploited vulnerability on the web today, which is using components with known security vulnerabilities. So where this typically happens is if I do an npm install on a React project, I believe somebody did a count not too long ago, pulls in like 43,000 packages, and it's not like Angular or anything else is any better. Trying to vet all those for security is nearly impossible. You know, even if I start up a Spring Boot project and I'm a Java developer, I'm going to pull in hundreds and hundreds and hundreds of packages too. So vetting all those and checking them for security vulnerabilities is frankly not something most of us are going to do. So here's how OWASP Dependency Check was designed to help solve that problem for you. So what it does, it scans your dependencies, and it compares them against the NIST, which is National Vulnerability Database, for any posted CVEs. The NIST in this and the nation in this is the United States, by the way. NIST stands for National Institute of Standards and Technology. It's a free and open source vulnerability database maintained by a couple of security-related people in the United States federal government. So it scans your dependencies against this database, and it looks for CVEs, which are basically security notices posted against various products that are put out by either researchers or the companies themselves. It supports suppression lists, report generations, failure depending on severity, a whole bunch of stuff. Good news, implementations, Java supported, JavaScript and .NET are all officially supported. Python, Ruby, PHP, Go, Swift, and C++ have experimental support, but they've been experimental for about a decade and it's worked just fine. So I think the maintainer maybe is just, I don't know, maybe there's some unknown bug I don't know about. I have personally used it on Python and PHP code for years without any problem. And the other implementations, it's got a command line, which we'll talk about the command line. It's got Jenkins plugins. It's got Gradle and Maven and Ant, although if you're using Ant, I have questions. Plugins for your Java code, and tooling all exists that hook into your various projects. What does it look like? Well, let's take a look at Java to start with. So on the left, this is if you're using Maven. This is what you'd have to add to your POM. Outside the version numbers now a little bit higher than that from when I did this. It's a plugin. It by default runs in the verify stage of Maven, and it looks pretty much just like this. You can supply it a suppression file. You can say, hey, how long do I care what the database being valid for? What it does is it goes through, and here's an example. What it scans, it looks for dependencies, takes 10 seconds or so to run after the database has been pulled down. On the command line, say I've got a .NET project. On the command line, it's either a shell script or a batch file, depending if you're running Windows or Linux or Mac OS, I guess. And you just call with some command line options, very well documented, of links all towards the end. For the DLLs, you're going to scan, and it goes ahead and scans those for you and reports out a list. You can also integrate as a OWASP dependency check, like an MS build test, is automatically run if you're just building your .NET project. PHP, again, this is experimental. Why it's experimental, it only supports Composer. Same thing, command line, just runs a dependency check. You give it the directory to scan, a couple different command line options, which we'll go over, and it again, will scan your Composer dependencies for any vulnerabilities. Relatively easy to set up. When I've done this in the past, once I get the hang of it or teach people how to do so, I mean, this is work that takes 15, 20 minutes to get it working on your projects. It also has Jenkins integration. There's a couple of Jenkins plugins you can plug in if you want. Jenkins plugin that you can install if you want. If you do that, it lets you print out very nice, pretty lists showing you maybe what it found. And it all displays right there for you in Jenkins. It also lets you fail builds, all that type of stuff without any issues, or I mean, all that good CI/CD, fail quickly, report fast. We want to fail quickly in the pipeline. All that stuff is just baked into it. You might be thinking, how bad can it be? When I first installed this, which is what the screenshot is of a pretty large project I was working on from a very large vendor that specializes in providing website software to the Fortune 500 or Fortune 100 companies. This is the result I got back. Not all these were end up being 100% CV, 100% valid, but this was a pretty common experience. Whenever I turn this on a project, I almost always find at least a dozen vulnerabilities. If you're talking about Java, they're oftentimes tied to JAR or to Jackson, the HP client, that type of stuff. And even .NET projects, same. Whenever this sucker gets turned on, it absolutely is catastrophic for its reporting. And just to give you an idea of what it looks like when you run it. So this is on my local machine. And if you want to run it outside of a pipeline, like locally, just to check it, another nice thing about this is you can, right? Developers can run it locally. They don't have to rely on some specialized tool that's only installed on the Jenkins server or only security has access to. Nope, it's a plugin or a batch file or a shell script. You can run wherever. We just call it, pretty standard Maven dependency check. This is kind of what it looks like as it scans my project. Okay, it fails. So it's telling me why it fails. It's giving me a very explicit thing. My Jackson data bind with this version has these listed CVEs, and I can actually go look those up and see exactly what they are. Or I can suppress them, or I can upgrade my Jackson data bind. Pretty easy stuff. And as you saw, it ran 4.68 seconds. Very quick. Now compare that to waiting for somebody on a security team to run a burp scan to send you an email 3 months after you launch a project, or right before you had to launch a project and fix it. Side note, while this does support JavaScript, NPM added support for this type of stuff with NPM like 6, I want to say, or 6.1. So if you run NPM audit right now, just straight up, just NPM audit, it'll do this exact thing for you. It'll scan your NPM package. It'll warn or flat out fail your project if you want it to. If it detects vulnerabilities, it'll also, you can pass it, I think, -- fix. It'll attempt to automatically upgrade your NPM packages. So this is also just natively supported as part of NPM now. I would highly encourage you to turn on NPM audit as part of your builds and at least fail on critical or highs. It may be moderates, you leave alone. Moderates are almost always what you see here in this screenshot, DOS attacks, denial of service, that type of stuff. I mean, they're bad, but they're not awful like cross-site scripting or maybe root vulnerabilities. All right, OWASP SONARQUBE rules. As usual, I ask for a show of hands. It's 2020. So look at your pet and wave your hand. I don't know. We're going to talk about, I want to ask how many, hopefully most of you are familiar with SonarQube. If you're not, SonarQube is a free and paid product. I don't work for them or anything. We tend to use them almost everywhere. That kind of specialize in static code analysis. That is, taking a look at your source code or compiled artifacts, running rules against them and determining, hey, you're doing something wrong or you could do this better. I mean, it does everything from why are you have unassigned variables, to what we're going to talk about now, which is integrate with security tool sets to be like, why are you taking in a string from a website and injecting it right into SQL command? Great stuff. So here's how the OWASP SonarQubes roll. There are several suggested rule sets that are built into the languages SonarQube supports, which is Java and .NET and JavaScript and Ruby and Go and all sorts of different ones that are baked in the base project. It also, I should mention, SonarQube is free for like the community edition. They have paid editions that add more support and also additional languages. For instance, if you need COBOL code analyzed, you need to buy the paid version of SonarQube. If you need COBOL code analyzed, I feel for you as somebody who's had to work with COBOL code in the last year. But anyway, there's several suggested rule sets that they run against your code and try to catch security. So what they typically end up doing here is they'll scan your code, look for stuff like I mentioned SQL, look for stuff where maybe you're like have a variable named password. It's probably a good indication you're maybe pulling in a configuration with the password unencrypted, anything of that nature. And they integrate into Jenkins and your whatever your build pipeline might be. Maybe that's GitHub Actions or Azure DevOps or something like that. And it'll also integrate to that. What you can set your project to do then is if one of these rules catch a critical vulnerabilities, they'll fail your build. And yet another tool for us detecting when developers maybe accidentally committed something up, didn't realize the security implications, so it's failed the build right away. What it looks like, it actually, I got a screenshot down here, which I don't believe my face is covering it. So this is kind of the type of stuff, like if I open this PR, that's what this is. This is a pull request from a project. It'll report back and say, hey, I'm using default HTTP client. Well, that's not compatible with TLS 1.2. Lots of reasons. Maybe that's not a big deal, but for most instances, you always want to be at least TLS 1.2 nowadays. As 1.1 and 1.0 is completely deprecated. 1.1 has, I think, a theoretical vulnerability. It's not reckoned to be used. Or in this case, it's complaining because I'm taking user-controlled input and I'm pasting it to a URL, which maybe user can use to try to force your whatever your service is to request internal APIs or something like that you don't want. So reports it inline, gives really clear indication what's going on, and lets you set quality gates so you can fail your builds. I should mention, by the way, in the repo and the link I'll share at the very end, there's a README and a whole Docker Compose and settings how you can set all this up on like your own personal computer if you just want to take play around with it locally, maybe see get it working, see kind of what it looks like before you decide to integrate into your own projects. It takes about an hour or so if you do everything, but if you are specific to Java or PHP, it's a lot quicker, including SonarQube. All right, Z attacks proxy. Z because we're pronouncing it the European way. Here's what attack proxy is. So this is a free product. Again, it kind of replaces a paid product. A lot of times you'll hear people using like Burp Suite or White Hat is a commercial product, but this is a free one, and it's an attack, specifically an attack proxy, which means it's designed to hit your site and probe for vulnerabilities. So it doesn't know anything about your site. You give it a URL, and it attacks it, and it tries to see, hey, what am I doing wrong? It looks for all sorts of common things. OWASP top 10 looks at everything from like SSLs turned off to you're vulnerable to cross-site scripting, and then outputs a report. It is, I should note, depending on your jurisdiction and the legality, this is something you only want to run against internal resources and probably without vetting it first. If you run something like this against somebody else's server without permission, depending on the country you're at and your legal situation, it could be a crime. So please don't ever do that. Again, it is actually a security penetration testing tool, and as such, you are conducting attacks on a web server. Again, in our case, for our build pipelines is for a good reason. We're trying to find stuff. But anyway, I always have to throw that in case you accidentally, I don't want to get in trouble. Anyway, there's a large customizable rule set and has integration points with Jenkins as well. And most importantly, it has pre-built Docker images, which means I don't have to worry about a weird commercial tool. I can just pull down a Docker image of this sucker and run it. So here are the couple different ways we have of running this stuff. It's got a GUI. It's just ancient Java Spring based. It looks like those old apps. If you're as old as I am, I'm that old, but from like the late 90s, this old swing Java GUI, but it does work. It's got a CLI, which is what we end up using for our Jenkins, I usually end up using. It's got a REST API if you want to do some custom instrumentation, and then lastly, it has a Jenkins plugin. All right, here's the other side. Here's what the GUI thing looks like. Like I said, look at this. Look at how glorious this thing looks like. Just beautiful, right? It is a traditional one. You give it a URL, it spits back a list. It's great if you're trying to just like play around with stuff, but for CI/CD, this isn't scriptable. It's not really something we'd end up using, but maybe you'd use it for exploratory testing. The one you're probably going to pick is a Jenkins plugin. So here's the good news on the Jenkins plugin. It's official. It's supported by OWASP. Has good integration with Jira, and it works. The bad thing about it is you have to install all this OWASP Zap stuff on your Jenkins server, which is a pretty heavy install. And depending on how you're doing your CI/CD pipelines, maybe you're spinning up a Docker container, a transient, then destroying it. It's a lot of stuff to install on your Jenkins server and to keep up to date. But it absolutely does work. If you have a more traditional Jenkins, or maybe just have a VM you spin up and leave touch alone for years and years and years, it's probably a-okay. As mentioned, it's great integration. You just kind of specify stuff, but it does require OWASP Zap to be running on the same container as Jenkins. The one I end up using in my build jobs is this one, and here's an example of me running it. They publish an official Docker image. Zap2 Docker-stable. You give it one of the predefined scans options, which we'll go over in a second, and point it to a URL, and it runs a scan for you. So a couple different options you give it. There's the quick scan, which is what I usually integrate into my build pipelines. This runs a very basic scan. It only will take a minute. It'll actually self-limit itself to a minute. And it's designed to test for the most egregious of stuff, like HTTPS being disabled, really common XSS turned on, that type of thing. The other one, I can run the other pre-configured one is baseline, which again is usually safe as well, usually very quick. The other one that has the option is active scan. So active scan will attempt to spider your entire website and do all sorts of attacks. It'll do everything from it'll attempt to SQL inject. It should not be considered safe, as not only is it legally, like I mentioned earlier, if you are vulnerable to a SQL injection attack, it could corrupt your database or do all sorts of crazy stuff. This one, active scan, it also can take a while depending on the size of your site. The active scan is something I will usually schedule. Like we'll run active scans against Stage or something like that once a day or once a week, depending on our build cycle, or maybe right before we have a release, our 2-week sprint, we're going to do a release build. We run active scan. It's scheduled to do 2 or 3 days ahead of time. Other thing about active scan I should mention, it's also incidentally a load test because of how often it pings your server and how much scripts it's trying to run against it. It also usually ends up pretty thoroughly trashing your app server or web servers, just trying to head with a load, depending on your environment and what the Zap is running on. All right. The other one option you have is a Zap API. There's a whole REST API built in for it. This is very, very, very feature rich, and it's amazing. I've only used it once when we had a security guy or a security gal in this case, actually ended up configuring and building a bunch of custom rule sets for our app. Best use is in Docker container setups where you build a bunch of scripts that it invokes. Also want to point out something amazing about Zap that they added in the last 2 years or year and a half is it's able to use OpenAPI, also known as Swagger documentations, to verify contracts are enforced. So you can give Zap your OpenAPI Swagger docs. It'll run it against your APIs, and if you say that it should have authorization, you don't. It'll fail and say, well, you're not requiring it, or this endpoint which isn't set to be secured is set to be secured, and those type of things. It's amazing. It's just a real easy way to verify your API is turned on and nobody forgot to add a. I usually pepper stories in here of all the terrible security stuff I've seen in my days, but a real common one, about 3 or 4 times, and usually about once a year, is somebody forgot to add, like, in Java to add authorize, or in .NET, authenticate or whatever on an API method, and suddenly it's like, oh, we can just hit this unauthenticated. Oops. This is the type of thing is designed to prevent that. Also, make sure your developers have OpenAPI contracts. And this runs really quick, by the way, unless your API service is huge. And I really do mean huge, and it's really easy to integrate as well into your normal, CI/CD deploy process. Some tips on this is it's kind of hard to figure out, right? We don't want our CI/CD pipelines taking a year and a half. That sort of defeats the purpose of having CI/CD. So it's usually run as a last stage in the pipeline. After the deploy happens, then I go ahead and run Zap. And that's the one I do. The other option, though, if you don't want to do it that way, is I mentioned earlier, you can run as a scheduled task, a cron job. Set it to run, once a day, once an hour, that type of thing. And another thing to keep in mind is, I mentioned earlier, it does consume a ton of resources. It'll easily bring a machine to its knees. So make sure you provision it well, give it someone decent, and to scale out as needed. And one of the drawbacks, if you run the same box as your Jenkins machine, just make sure the Jenkins machine is pretty beefy, because you might bring down the Jenkins machine itself as it sucks up all available CPU and RAM. SSL Advanced Forensic Tool, OSAFT, just rolls off the tongue. So another free tool. TLS certs are the #1 cause of me realizing I'm going to lose a day of my life as I try to troubleshoot some god-awful TLS problem. So OWASP is very nice and published us a free tool that I call SSL Checking Tool for the Lazy. It takes an cert, scans it for the most common problems. And best part about it is it's either Perl or Docker image, and it's extremely easy to use. Like, extremely easy. How easy? Well, if I would click over there correctly, there's a Docker image provided that I can just do this. It'll scan these for various things. Here I'm just checking this website to make sure that it is correctly, like TLS 1.1 is turned on. Here I'm checking to make sure that TLS 1.1 is turned off, and it'll fail it if not. So you can tell it's really easy for us to implement these into our build pipelines. Maybe we're having infrastructure as code. Maybe I'm using Ansible. Free shout out to Ansible or Terraform. And after I'm done, we'll make sure that whatever host I stood up is using a cert that is valid and has all the cipher suites and all that type of stuff set up correctly. This is a quick way to run through and verify that. Also very important, it'll also fail if, I don't know, your cert's about ready to expire or is using an invalid root cert. All those type of stuff that, in addition to security, causes me a lot of heartache just from I'm trying to build infrastructure and stand up infrastructure. Cert issues, man. Okay, one of my favorite tools, though. It really does catch a ton of issues that you wouldn't think about. Once you integrate it, you'll probably always want it. Application Security Verification Standards, which is definitely a huge mouthful. But it's great. It's a guidebook to securing your app. It's a series of vetted checklists that is designed for you to go through against whatever application you're building and be like, are we doing this? Are we not doing this? There's a ton of documentation available. It is just documentation on how to use it. It is also a great thing to do against some security critical, like your DevOps infrastructure, to run ASVS against it. Cannot tell you how many times I get to a company or something and I look at Jenkins and the password is like admin or something like that. Or Jenkins isn't running on HTTPS. ASVS, if you look at the type of stuff it ends up doing, it's really designed for you to take a look at everything in your project, kind of look through it, see what's going on, and score it, right? So it's doing everything like verify that all password fields and not echo the user's password enter, verify authentication things are checked. It's just a huge audit. If you've ever done a PCI audit, a credit card audit, it's very similar to that, without being quite as focused on like a specific data field like that, but more focused on the overall security of the application. All right, one of the last things we're going to talk about is the OWASP cheat sheet series. So what the cheat sheet is designed to do, it helps prevent against misconfiguration by providing a bunch of vetted documentation. So it is a huge series of cheat sheets. They're like 1 or 2 pages to handle common configuration tasks. And what do I mean by common? It's everything from how to store passwords to access control, logging, key management, secure programming in various languages, just an absolute ton of resources on this. The really amazing thing about cheat sheet, at least one of the amazing things I love about cheat sheet, is you can have some random problem like how do I store a password securely, and pick any languages, and the cheat sheet will be a nice 1-pager on exactly how to do it. Or how do I handle session in PHP? There'll be a cheat sheet series on it. There's no excuse if you use this tool, if you'd really be able to understand and kind of figure out just how to handle all these problems. Oftentimes what I find with developers or architects when they're designing something and maybe a vulnerability slips in, it's not because people are bad, they just didn't really have an easy resource and they tried to do the best they could and didn't understand what they were doing was wrong, because security is very hard, right? Encryption is very hard. All this stuff it's so easy to accidentally paint yourself in a corner and not really understand what you're implementing and break it. So the nice things about cheat sheet is it's just, here's a quick 1-page, do exactly this and you'll probably be fine. One of the things that prevents the most in my experience when I've shown it to developers is the insecurely storing a password problem. It's hard to figure out which encryption algorithm to use, and oftentimes the developer sees encryption and just picks one, and which is bad, as you usually want to store passwords with a specific hashed and using a specific type of hash function to store your passwords. As thanks to the rise of Bitcoin, it's actually really easy nowadays for folks to run huge amounts of hashes and kind of crack passwords. Cheat sheet, anyway, it has all those type of resources, again, not just password, but logging and session and all that type of stuff. Again, there's the link right there, cheat sheet series at OWASP.org, has all those amazing resources for you. Here's a hidden level, a bonus tool, as I call it. It's not OWASP, but it is another open source tool, so I hope you'll forgive me. Mozilla puts it out. It's called Mozilla Observatory. So what this is designed to do is it scans your website for common HTTP header best practices. So you give it a URI, and it scans, reports those following best practices for HTTP. For those who aren't familiar, there's a couple of security things that have been added recently in HTTP protocol, specifically around enforcing and helping secure websites. Some of the most common ones are HSTS, which is strict transport security, which is basically a way of saying this website should never be accessed over HTTP no matter what. There's also things like HPKP, which is public key pinning, which is a way of publishing saying this public key on this SSL for this site should always be match this 100% of the time. This is designed specifically to break man-in-the-middle attacks, especially man-in-the-middle attacks we've been seeing from like nation-state actors, where people are trying to insert themselves between users trying to access something like Twitter and snoop their traffic. This especially actually came out of really the protests in Africa in 2011, 2010. Anyway, I was also supposed to check around cookies and redirections and all that type of stuff. Documentation is available here, but it's really not that hard to use. So I'm gonna go back to my amazing Windows command here. So it's npm install -g observatory, nothing terrible. Once you install it, at that point you can just run, so I'm running as my website, or our website I should say, my company's. It takes really quick to implement. Here it's reporting what it reports back to me here is what's going on, right? So it's flagging me saying invalid certificate chain was encountered, HSTS cannot be set, XSS protection. And if you went to this URL, it would give you a whole list for all the reasons these are bad and why you should turn them on. Okay. And what you can do as part of your build pipelines, or what I end up doing most part of my build pipelines, you can also set these to fail. So you could say, I think it's -- fail. So if I remember the syntax right, I believe that's right. It'll actually return a 1. It'll actually fail and return an error to your console, and so fail your build because you didn't have the correct security header set. So another really easy way to make sure that whatever you're deploying is correctly set up with all the right rules. So let's go through some hopefully quick review of all the different amazing tools we discovered as I flash over real fast here. So what we went over was dependency check. That is either a Jenkins plugin or a Maven plugin or command line that is designed to scan your tools for vulnerabilities. Extremely easy to implement. There's a couple different ways. You can do the command line, Jenkins, you can do a Maven plugin. You can set it to fail your build depending on the severity of the vulnerability, all sorts of different configurations. There is the Z attack proxy, the ZAP, that is an active attack surface, which is designed to hit your website and probe it for vulnerabilities, typically implemented at the end of your CI/CD pipeline. There's the SSL OSAFT, rolls off the tongue, which is designed simply to make sure that whatever certificate you're deploying is set correct. There's our SONARQUBE rule set, which is a set of static code analysis, which what it does is it hits your tools, hits your code and looks for common mistakes that developers might make that are security impacting. And then we talked about the 2 different documentation ways, the application security verification standards, which are a long checklist of things you should check to make sure that your software you're building is safe, and the cheat sheet series, which is almost exactly what it sounds like. A huge list of cheat sheets on how to do secure passwords and secure session and all that type of stuff. So with that said, when you do this anyway, there is one last thing I do want to talk about real quick. Oftentimes when we're DevOps professionals, we don't really think about how critical our CI/CD pipeline software is. Typically, whatever we're building and deploying has the keys to the kingdom, right? If I compromise a Jenkins server or a DevOps user's account, I have access to configuration, code, deploy keys, firewalls, everything. There's been a lot of reports. I've referenced some Forrester reports that believe that one of the most critical things under attack or will be under attack in the next 5 years is CI/CD infrastructure because it's not properly secured. So if there's one thing takeaway I would have from all this, besides, hey, look at all this amazing free software that's pretty easy to set up, is really think about your CI/CD setup and pipelines and how secure is your environment? Are you enforcing passwords? Are they set to expire? Do you have 2-factor turned on? All that type of stuff, because if somebody gets access and cracks that Jenkins server, it's going to be a real bad day for you and a real bad day for your users. So with that said, please go forth, build yourself rugged software. Use these tools and resources to make sure that your users have a secure, good web browsing experience. Here's a list of all many of the stuff I talked about: the top 10 project, ASVS, OWASP ZAP scans. With that said, all these slides are available, and the demo code is available at that link. And you can always ping me on Twitter or send me an email if you have any questions. But I believe Dylan is here in case anybody had any questions.
I am indeed here. So there are currently no questions in the chat, but maybe that's just folks letting the information sink in, or perhaps you've achieved complete enlightenment, which is always a great achievement for a speaker.
I could have achieved complete enlightenment for everybody, 100%.
There is actually just you talking at the end there about your pipeline reminded me of one of the oldest sort of computer security stories in history. Way back, this is kind of I think this is the earliest versions of Unix, like one version after Multics. And there was a pair of viruses that were Robin Hood and Friar Tuck, they were called. And basically, they were just cron processes or daemon processes. They ran in the background, and if you killed one, the other one would restart it. And if you killed the other one, the first one would restart it. And it was almost impossible to get rid of because when it infected a system, it would infect the C compiler. And it would also, not only would it infect the C compiler so that if you tried to recompile the programs from source, these viruses would be re-injected, but it infected the C compiler so if you tried to recompile the compiler, it would preserve its own behavior. So the only way to get rid of this thing was to find a site that hadn't been infected and get a copy of the source code for their C compiler on tape and rebuild the thing from scratch and then rebuild everything up from there. So yeah, this is going back probably 1960s, it must have been, 67, 68. So yeah, the earliest example I could think of a delivery of CD pipeline being compromised for a security
vulnerability. And you have the
vulnerability.
exact same problem nowadays if somebody got access to your Jenkins and he decided to inject code into your whatever compiler.
So we got a question in the chat here from Boris. Hey Boris, how you doing? So Boris says, can you elaborate why the Jenkins plugin for Zap needs to be inside the same container? Why is that, Bill?
So the deal with that is the Zap plugin itself requires a bunch of software installed with it. I'd have to look at the whole list. I believe it's running Python, Perl, among other stuff. And without that there, so in the Jenkins plugin, all it attempts to do when it goes through and runs is just run that script. It's expecting that script to be on the global path. So if it's not there, it's going to fail, which is why the Docker container I mentioned is a little bit preferred. But yeah, that's the whole reason. The entire plugin is just, if you look at the source code for it, all it's attempting to do is run those same tools, expecting it on the global path on the Jenkins server. So they must be installed.